Okay, today we're going to be talking about similar figures, and I will be honest that today's lesson is very vocabulary and definition oriented and not a lot of examples. So I need you to make sure that you understand these words. The first and most important word for right now is our similar figures. I want you to understand that similar figures doesn't mean that they're the exact same. These are figures that actually have the exact same shape, but their sizes are proportional. So it's not just that they're smaller or bigger, they actually are the exact same shape, just either shrunk down or blown up. And the big thing you need to remember is this part right here. They are proportional. And then remember, proportion means two ratios that might look different, but they mean the same thing. So this right here, I'm giving an example. I've got a quadrilateral on the left that's much bigger. And then I'm taking it and shrinking it down, and it's much smaller on the right, but it's the exact same shape, just different sizes. Now let's go ahead and look at the next vocabulary word, because this is going to help us determine if they really are the same shape, just different sizes, or do they look like they're the same shape, but they're actually not. So let's go ahead and take a look at corresponding sides. Corresponding sides, well, what those are our matching sides of two or more polygons. It would be like if I could take this first shape right here, and I could take it and shrink it down, and I could even flip it over so I can lay one shape directly on top of the other. And the sides that would actually line up are called corresponding sides. So they're matching sides. And if they really are similar figures, meaning they're the exact same shape, just different sizes, well then the corresponding sides will be proportional. So let me give you an example. Here I've got two triangles. They're not facing the same direction, and they're definitely not the same size. But if it was possible, if I could actually take this side right here, AC, and I could take this whole entire triangle, flip it over, and then shrink it down so it was the exact same size as this shape over here, well, what side would be laying on top? Or which side would this AC, which side would it be laying on? I'm hoping you would realize it would be laying directly on top of this side, EG. Those are called corresponding sides. So again, if I was able to take maybe this side right here, AB, and I was able to, again, shrink down this triangle, flip it over, I would take that side and lay it directly on top of EF. Those are corresponding sides. And of course, my side BC here, if I was able to take and shrink it down and flip it over, I would lay it on top of the side FG. Those are all corresponding sides. But I'm not sure if this is really the exact same triangle that I just shrunk down or not. So to make sure, I know right here that it says that if they are similar figures, then I know the corresponding sides will actually make a proportion. So let's take our pink sides first. Let's take AC. AC, I know, was 26. And that matched up with side EG, which I know is 13. Well, if I want to go ahead and reduce that, 26 over 13, well, that would give me 2 over 1. That would give me a ratio of 2 over 1. Okay, well, that's just one side. What about the other ones? Because all corresponding sides should be proportional. So let's go ahead and take the green side now. Let's see what kind of a proportion I get. AB would be 16, and it's laying directly on top of EF, which is 8. Well, if I reduce that, that also gives me 2 over 1. So far, absolutely, this is giving me that same ratio so far. But that's only 2 of the corresponding sides. I need all corresponding sides to be proportional. So let's look at the blue one. BC, well, that was 14. It would lay directly on top of FG, which was 7. And when I go ahead and reduce it, I get 2 over 1. That shows me that each one of these corresponding sides, no matter which side I pick, come up with the exact same ratio, which means they are proportional. And since those corresponding sides are all proportional, then I have this question for you. My question says, are the shapes actually similar? But then it definitely says to explain. I'm hoping that you're going to be able to mathematically explain are they similar? Yes. And now my explanation. The shapes are similar, but why? Why would you tell me? What mathematical reason do you have to tell me that they are similar? They are similar because what was the reason we just found out? The corresponding sides are what? I hope you're not going to say are the same, because they're not the same. They were definitely not the same. But the corresponding sides are, they all made the same proportion. So they are proportional. That is the key reason. You have to be able to justify mathematically why they are similar. Now, if just one of them came up with 3 over 1, then I could use that other kind of reverse explanation of no, they're not similar because the corresponding sides are not proportional. So that's what you're looking for. The shapes are similar because those corresponding, oh, I forgot the sides on there. Corresponding sides are proportional. Those corresponding sides are proportional. So that means, yes, they are actually the exact same shape, just different sizes. Now, very similarly, we have corresponding angles. Again, corresponding angles are matching angles of our 2 or more polygons. And just like in similar figures, if they really are similar, the corresponding sides would be proportional. Well, if they really are similar figures, those corresponding angles will actually be congruent, meaning equal, equivalent. They must be the same. It doesn't matter what size it is. The sides have to be, or the angles have to be the same if they really are similar. So let's look at this one. You can see I've already kind of given you a nice little outline that angle R here would lay on top of angle K, and they're both in pink. S would lay on top of L, which I put in blue. T would lay on top of M, which would be green, and my U would lay on top of N, which is an orange. So those are my corresponding angles, and I wrote them out here for you. It says my angle R corresponds to angle K. They would lay directly on top of each other. Angle S corresponds to angle L. They would lay right on top of each other. T corresponds to M. U corresponds to N. And so if these really are, they very much look like they're the same shape. But if they are truly the same shape, then the angles that are inside should be exactly the same. So let's look at this first one. Angle R corresponds to angle K. Well, how much is angle R? Angle R is 100 degrees. So if it really is the exact same shape, just a different size, its corresponding angle K, should be exactly the same. But in the picture, the diagram, I can see it's 110 degrees. That means these are not equivalent. They are not congruent. And the minute I can see just one angle not congruent, I automatically know that, yeah, they might look about the same shape, but they actually are not the exact same shape. So when I say, are these shapes similar, which is my question to you right here, and explain, well, would those two be similar? I'm hoping you would say no. But now, how would you mathematically explain your answer of no? You can't just give me no. You have to justify. The shapes are not similar. Now again, you're saying no, they're not, which, okay. Why do you think so? Because, well, does it have anything to do with their sides not being proportional? You don't know their sides, so you can't use the corresponding sides are not proportional. We were looking at the inside, those angles. So it's because corresponding angles are not, and what would you say? Are they not proportional? No, that only has to do with sides. We want to say they are not congruent. They are not congruent. So when I'm looking at the sides, I'm looking at a proportion. When I'm looking at the inside, the angles, I'm seeing if they are congruent. So that's what we're going to be working on in class, giving some shapes and trying to justify if they really are the same shape, just different sizes, or are they not? Are they not similar? So we'll be working on that in class today. So bring your notes with you and your brains, and we will get started on some more.